So today we will discuss about the power saving we make in multi-stage compression in comparison with a single stage compression. So before going to the multi-stage compression, first thing that we should understand that what happens in case of a compression. In case of a compression, the working substance is taken in, then it is compressed, and then it is sent to a storage vessel, and from there it is used in other places. So as far as the single stage compression process is concerned, first thing we have to consider the PV diagram. First we take in the working substance, then it is compressed, and then finally it is delivered to the storage vessel. 1, 2 represents your induction process, 2, 3 represents your compression process, and 3, 4 represents the delivery process. The basic difference between compressor and the turbine and engines, that both turbine and engines are prime movers which actually produce mechanical work, whereas compressor is a device which compresses the working substance utilizing some power. So it is a power consuming device, not a power generating device. And the area coming under the PV diagram represents the work input to the compressor. So area 1, 2, 3, 4 represents the work input given to a compressor. Similarly, we have to consider the multi-stage compression process and how work input is saved in comparison to the single stage compression process. Here also the working substance is taken in, then it is compressed to an intermediate pressure. After that it is taken to the second stage after providing the intercooler, and then the second stage of the compression is carried out, and finally you get the desired pressure. In this case, this is the saving in work input we obtain. So let us consider that first of all the working substance is taken during the induction process 1 to 2. After that from 2 to 3 it is compressed to an intermediate pressure. At that pressure we provide an intercooler arrangement where it cools the working substance at constant pressure. This is represented by 3 dash. Then it is taken to the second stage of the compressor, and in the second stage of the compressor it is compressed to the final pressure which is to be achieved. At that pressure it is delivered to the storage vessel. Now how this saving is actually taking place and why the second stage of the compression is not starting from this point, why it is starting from point 3 dash, that we must analyze. All of us know that as for combined gas equation, PV by T is equal to constant, and in this case the intercooling is actually carried out at constant pressure. So when it is carried out at constant pressure, this combined gas equation PV by T is equal to constant reduces to V by T is equal to constant. So in intercooler we actually cool it, that means we reduce its temperature. So as there is drop in temperature, there will be consequent drop in volume. So for that reason the second stage of the compression will not start at point 3, rather it will start at point 3 dash, and this is the net saving in work input we get by providing the multi-stage compression system. Next important thing, that by increasing the number of stages we can make more and more savings when it comes to the work input, but usually the compression is either carried out in 2 stages or in 3 stages, because if you incorporate more number of stages, then you are likely to encounter some other difficulties. That actually is the basic difference between the multi-stage compression and the single stage compression, and this is the reason that we make savings when it comes to your multi-stage compression in comparison to single stage compression.